Clicking through Cloud UI sucks. Running CLI commands one after another sucks even more. Good thing there's infrastructure as code, a better way to manage all of this operational overhead. Today, I'm diving into Terraform, the tool that's revolutionized how developers handle infrastructure. Traditionally, you'd click through a UI with some good old ClickOps or run some one-off bash scripts, a process that's inconsistent, error-prone, and a pain to share with others. Every time you deploy a database, network, or VM, you're building infrastructure. Infrastructure as code transforms these manual processes into repeatable, version-controlled configurations. It streamlines how you define infrastructure, making deployment faster and more reliable. A Terraform provider is essentially an interface to any API that works with the Terraform language. You can write your own, but for most cases, one will probably exist. Whether you're working with AWS, Google Cloud, Azure, or other services, Terraform communicates directly with them to create infrastructure. You can also manage DNS with Cloudflare, repositories with GitHub, and even order a pizza while you're waiting for the rest of your code to run. This consistent interface is what makes Terraform unique, one tool to rule them all without the vendor lock-in. Except for HashiCorp, of course. Terraform has three core components working together to deploy your infrastructure. First, your configuration code, written in HashiCorp configuration language. Think of it as your infrastructure's blueprint, defining your resources, configurations, and how they connect. While it may seem unstructured at first, you'll pick it up quickly with some practice. Second, the state file, Terraform's working memory. This file tracks what Terraform's last built and monitors your deployment resources. When either changes, the state file alerts you during planning and ensures deployed resources match your code's definition. Finally, the actual provisioned infrastructure, the real-world resources Terraform creates and manages for you. Getting started with Terraform follows a simple three-step process. First, run Terraform init to set up your working directory and download providers. This fetches all the resources and definitions needed for your code. Next, Terraform plan to preview what the Terraform will change. Trust me, you don't want to skip this step and be like someone I know who lost access to their Google Cloud accounts. Finally, Terraform apply executes those changes once you're satisfied with the plan. Terraform handles all the create, update, and delete operations to finalize your infrastructure. This look before you leap approach means that you're rarely surprised by what Terraform does to your environments. Let's get Terraform installed. You have several options. I recommend using tfswitch to manage Terraform versions. It automatically selects the right version based on your project's constraints. Just run tfswitch in any folder, and it will automatically pick up the correct version. For this demo, we'll be building a Google Cloud storage bucket that could host a static website. Let's create a file called main.tf. Though honestly, the name, folder structure, and organization are all flexible. We'll cover best practices later, but for now, this is our configuration. The provider block tells Terraform which provider to download and what settings to use. The documentation has all the details, but these basics are more than enough to get us started. The resource follows a simple pattern: resource keyword, resource type from a provider, and a unique reference name for this specific resource. Now let's see Terraform in action. We'll run Terraform init here, follow it with a Terraform plan, and finally a Terraform apply. Terraform will ask you to confirm the changes, type yes, and just like that, we've created a Google Cloud storage bucket ready for hosting. Anyone on your team can use these exact same files and configuration to deploy identical infrastructure without memorizing complex commands or clicking through console screens. While Terraform has dominated the infrastructure as code space, it's worth understanding the alternatives and when they might be a better choice for your needs. Cloud-specific options like AWS CloudFormation, Azure Resource Manager, and Google Deployment Manager offer deeper integration with their respective platforms but lock you into their ecosystem. Programmatic approaches like AWS CDK and Pulumi let you use familiar languages like TypeScript or Python instead of HCL, which may feel more natural if you're primarily a developer. For Kubernetes-focused teams, tools like Crossplane provide a more native integration with the container orchestration ecosystem. The right choice ultimately depends on your team's skills, existing investments, and infrastructure complexity. So why is Terraform still dominant? It offers exceptional multi-cloud support with its massive provider ecosystem that covers most organizational workflows. The barrier to entry is relatively low, which is one of the key factors to making it accessible to most teams. Plus, the large community also means that there are plenty of examples and modules for almost anything that you would ever need. You would rarely need to reinvent the wheel. Terraform shines when you need one tool across multiple environments or providers, want a balance of power and simplicity, or value a strong community support with ready-to-make examples. Other tools might work better when you're fully committed to a single cloud provider, you prefer working in a familiar programming language rather than HCL, or if you need specialized Kubernetes integration. In that case, Crossplane is definitely the way to go. So what about OpenTofu? This new-ish open source alternative emerged after HashiCorp changed its Terraform licensing in 2023 of August. Initially, there weren't many compelling reasons to switch unless Terraform was core to your business strategy. Today, the story's different. OpenTofu offers several advantages over traditional Terraform, such as early variable evaluation, state encryption for better security, the exclude flag, which is more targeted than the target flag in Terraform, my personal favorite, for each in provider configuration blocks, and plenty more improvements. If your team is just starting with the infrastructure as code, I would seriously consider using OpenTofu instead of Terraform directly. It maintains compatibility while adding useful features and a truly open source future. Infrastructure as code is transforming how we build and manage systems, with Terraform at the forefront for teams who are seeking flexibility, power, and consistency with a low bar of entry. We've covered the basics today, but there's so much more to explore, from remote state management to modules, to workspaces and advanced deployment patterns. Thanks for watching. Drop a comment below about what specific Terraform topics you'd like to see next, such as Terraform variables, modules, or structuring of complex projects.